Welcome to the deep dive. If you've been keeping an eye on AI content generation, especially for 2D images, maybe even video from text prompts, it's been pretty incredible. But you've probably asked yourself, what about 3D? Building really good 3D assets, that's always been a much heavier lift. Takes skills, takes time. So that's our mission today. We're diving into Hunyuan3D 2.1. It's a system from Tencent Hunyuan, and it aims to kind of revolutionize how we make high-quality 3D models. Just from one single image, we're going to unpack how it works, its main parts, and really show how it's trying to bridge this gap in 3D generation, making something complex feel more accessible.
That's right. I mean, 3D content creation, it's always been notoriously complex. Usually you need serious expertise, things like data processing, model training. It often keeps it locked away, mainly for researchers and developers.
Right.
Hunyuan 3D 2.1 serves as a really good case study for tackling these issues. The whole system is designed to generate a full 3D mesh, complete with textures, straight from just one image. It simplifies a traditionally very difficult process.
And something that really stands out here is that it's open source. That feels like a big deal in this space, which hasn't really had a strong, scalable foundation model everyone could build on. Hunyuan 3D 2.1 gives us that foundation. It's based on two main models, Hunyuan 3D DIT for the actual shape, then Hunyuan 3D Paint for adding the textures. This modular approach separating shape and texture is pretty smart. It offers a lot of flexibility, like you could just generate the shape, the mesh without texture, or maybe apply these realistic textures to your own custom models.
Definitely. And when we talk about getting that high-quality, high-fidelity 3D shape, the cornerstone is Hunyuan 3D DIT. You can think of it as the system sculptor. It actually has two main parts working together. First, there's the Hunyuan 3D Shape VAE. This is like a very clever compressor or translator. It takes a complex 3D shape, say a detailed mesh, and boils it down to its essence, a sequence of mathematical tokens in this hidden latent space. It uses the 3D coordinates and the normal vectors, which are like tiny arrows showing the surface direction. Then its decoder part predicts something called a signed distance function, or SDF. Imagine mapping every point in space and knowing exactly how far it is from the object's surface. Super precise. This SDF blueprint is then turned into a standard triangle mesh using an algorithm called marching cubes. What's really neat is how it uses mesh surface importance sampling for sharp edges and variational token length to capture tiny details without smoothing them over. That's key for usable models.
Okay, that VAE part sounds like it creates a really precise digital skeleton or blueprint. So that gives us the structure. But what about the other part, the Hunyuan 3D DIT itself, the diffusion transformer? How does that connect to the image we feed in?
Right, the second piece is the Hunyuan 3D DIT. This is a flow-based diffusion model, kind of like the ones powering some of the advanced 2D image generators. It's trained specifically on that latent space blueprint from the shape VAE. Its main job is to look at the input image and predict the correct sequence of those shape tokens. To really understand the image details, it uses a very large, powerful image encoder DynaV2 giant. It's excellent at pulling out visual features. And before it even starts, the system smartly removes the background and centers the object, so the AI is just focusing on the thing itself. This diffusion transformer uses 21 layers and something called cross-attention to essentially translate the image features into that latent code. That's how it generates such detailed and accurate shapes based on the picture.
Okay, let me see if I've got this flow. You give it an image. The DIT part, using that strong DNOV2 vision, understands the image. It then uses that understanding to generate the detailed shape blueprint via the shape VE, and that blueprint becomes the 3D model. That sounds sophisticated just for the shape. So once we have that intricate 3D form, how does it get that realistic look? The textures, the materials that make it seem like it belongs in a game or a movie.
Ah, that realism, yeah. That comes down to an incredibly rigorous data processing pipeline. It's absolutely fundamental for both the shape and the texture models. You can't get good output without good input. For shape generation, they gathered over 100,000 3D models, some textured, some not, from well-known public datasets, ShapeNet, ModelNet 40, Thing10K, Objaverse, quite a collection. For the textures, the dataset was even more carefully selected. Over 70,000 high-quality entries from Objaverse XL, all human annotated and filtered using really strict rules to ensure top quality. The shape data itself goes through several vital pre-processing steps. First, normalization, everything gets scaled to fit inside a standard unit cube, standardizes the space. Then, water type processing, this is crucial. If a model has tiny holes or gaps, this step fixes them using signed distance fields and marching cubes again, creating a perfectly sealed surface, essential for things like 3D printing or simulation. Next is SDF sampling and surface sampling. This involves digitally measuring the object at millions of points, both near the surface for detail, especially in curved areas, and uniformly through space for overall structure. And finally, condition rendering. They generate 150 different virtual photos of each object from various angles, using a specific sequence for uniform coverage, even randomizing the virtual camera's field of view and distance. This teaches the AI the object's appearance from all sides. For the texture data, it's similarly detailed. They render views from 4 different elevation angles, and for each angle, 24 views rotating around the object. From these, they generate not just color maps, but also maps for albedo, the pure surface color without lighting, plus metallic and roughness properties, and HDR and point light images too. All this uses random viewpoints and changing lighting, teaching the AI to create textures that look right under any lighting condition in the final scene.
Wow, that sounds like a massive amount of work just preparing the data. Almost as complex as building the AI models themselves. Getting that perfectly structured, high-quality 3D data seems like it must be the secret sauce, really, for getting those incredibly realistic results.
It absolutely is foundational, and all that meticulous prep work feeds directly into Hunyuan3D Paint, the texture synthesis model. This isn't just about applying color. It generates what are called PBR material texture maps, specifically albedo, roughness, and metallic maps. PBR stands for physically based rendering. It's basically teaching the AI how light actually behaves in the real world, following principles like the Disney BRDF model. So instead of just a flat color, it understands surface reflectance, how shiny or matte something is, how metallic it is. That's what gives it that hyper-realistic look, adhering to industry standards for rendering. Hunyuan3D Paint uses some key innovations to pull this off. First, a spatial aligned multi-attention module. Think of it as processing the color, albedo, and the material properties, metallic roughness, in parallel, but ensuring they line up perfectly spatially. It even passes information directly from the albedo part to the material part to keep them aligned. This helps avoid seams or mismatches. Then there's 3D-aware rope, rotary positional embedding. This injects 3D spatial information right into the model, which significantly improves consistency across different viewing angles. It tackles common problems like texture seams or ghosting artifacts. And lastly, an illumination invariant training strategy. This forces the model to learn the true albedo, pure color, and accurate material properties, separate from any lighting or shadows present in the training data. It does this by making sure the outputs are consistent even when trained on images lit very differently.
So it's really about giving the AI a deep understanding of material physics, not just painting by numbers. That sounds incredibly sophisticated. These techniques seem vital for making the textures look not just good, but consistently good from any angle. Remarkable detail.
It really is. And they didn't just build it, they tested it rigorously. Hunyuan3D 2.1 was evaluated in 3 main areas: the 3D shape generation on its own, the texture synthesis, and then the complete end-to-end asset creation. For shape generation, they used metrics like ULFP and Una3D. These basically measure how well the generated 3D mesh matches the input image or text description. Compared to other top models, Michelangelo, Craftsman 1.5, Tripos-G, Hunyuan3D DDT consistently performed the best according to their results. Visual comparisons also back this up, showing it could capture really fine details like on roly-poly toys, the number of calculator buttons, rake teeth, even complex fighter jet structures. And critically, it produces watertight meshes, meaning they're solid and usable. For texture synthesis, they use different metrics, things like FID, clip FID, LDPSs, which measure perceptual similarity and quality. Again, Hunyuan3D Paint came out on top compared to models like SyncMVD IPA, TextGen, and even the previous Hunyuan3D version. The evaluations clearly showed its superiority in texture quality. And finally, looking at the whole process, image to complete 3D model, they benchmarked against Step 1 X3D, 3Dtopia XL, and some commercial systems. The conclusion was that Hunyuan3D 2.1 not only creates the highest fidelity PBR textures, but also tends to produce better geometry, mitigating issues sometimes seen with other methods.
Okay, so the results seem clear. It's not just incremental progress. It looks like it's setting a new standard for automated 3D creation from images.
Yeah.
So what does this kind of superiority actually mean? For our listeners, for people working in 3D, what's the impact?
Well, Hunyuan3D 2.1 is genuinely groundbreaking because it brings together that high-fidelity geometry and the really sophisticated PBR material synthesis all within one open-source package. Its architecture allows for the rapid creation of what they call studio-quality assets. Assets with really exceptional visual quality, ready for use in professional pipelines.
Right, and the fact that Tencent decided to open source Everything. The data processing scripts, the training pipelines, the actual model weights, and that feels huge. It genuinely makes this advanced 3D AI generation accessible to a much, much wider audience. Think about workflows in gaming, VR, industrial design. This could seriously accelerate things and maybe unlock new creative avenues that were just too difficult or expensive before. It definitely makes you think. Given these leaps in generating entire detailed 3D assets from just one picture, what kind of new creative tools or virtual experiences might become commonplace, accessible to almost anyone in the next few years? Something interesting to ponder.